This essay will guide you through creating a simple yet effective secure access system using an Arduino. This system utilizes RFID technology for authentication and a display for user feedback. RFID, or radio frequency identification, uses electromagnetic fields to automatically identify and track tags attached to objects. This technology is widely used in access control systems, payment systems, and inventory management. Our system will consist of an RFID reader, an RFID tag, an Arduino board, and an LCD display. The Arduino acts as the brain of the system. The Arduino will read the unique identification number from an RFID tag. Then it will check if the ID matches an authorized list stored in its memory. If the ID is a match, the system will grant access. It will also display a message on the LCD screen indicating so. If the ID is not a match, access will be denied, and a corresponding message will be shown on the display. This project is not only a practical application of Arduino but also an excellent way to learn about RFID technology. By the end of this guide, you will have a fully functional access control system. You will also have the knowledge to expand and customize it further based on your needs. Let's get started. Before we begin, gather the following components. Arduino board. The Arduino Uno is a great choice for beginners. RFID module, MFRC 522. This module will read and write data to RFID tags. RFID tags. You will need at least one RFID tag to test the system. LCD display 16x2 alphanumeric. This will display messages to the user. Jumper wires. These are used to connect the components. Breadboard optional, for easier prototyping. USB cable, to connect the Arduino to your computer. Power supply, 9 volts DC, to power the Arduino. Make sure you have all the necessary components before proceeding to the next section. Now let's put everything together. Follow these steps carefully. Step 1. Setting up the Arduino. First, download and install the Arduino IDE from the official Arduino website, arduino.cc. Connect your Arduino board to your computer using the USB cable. Open the Arduino IDE and select the correct board and port from the Tools menu. Step 2. Connecting the components. Connect the RFID module to the Arduino as follows. RFID VCC to Arduino 3.3 volts, RFID GND to Arduino ground, RFID RST to Arduino pin 9, RFID SS to Arduino pin 10, RFID MOSI to Arduino pin 11, RFID MISO to Arduino pin 12. Next, connect the LCD to the Arduino, LCD RS to Arduino pin 12, LCD enable to Arduino pin 11, LCD D4 to Arduino pin 5, LCD D5 to Arduino pin 4, LCD D6 to Arduino pin 3, LCD D7 to Arduino pin 2, LCD RW to ground, LCD VSS to ground, LCD VCC to 5 volts. Step 3. Programming the Arduino. Copy and paste the following code into the Arduino ID. CPP hash, include hash, include hash, include hash, define SS underscore, pin 10, hash define RST underscore pin 9, MFRC 522, MFRC 522, SS underscore pin, RST underscore pin, liquid crystal LCD 12115432, void setup, serial.begin 9600, spy.begin, MFRC 522.pcd underscore init, lcd.begin 162, lcd.print access control, void loop, if, exclamation mark, MFRC 522.pick underscore is new card present, if, exclamation mark, MFRC 522.pick underscore read card serial, string content equal sign for byte I equal sign 0, I MFRC 522.uid.size, I++, content.to uppercase, if content.substring 1 equal sign 6 BA 1811C / change, here the UID of the tag card, else. Modify the code to include the UID of your own RFID tag in the line. You can find the UID of your tag by running the code once and scanning the tag. The UID will be printed in the serial monitor. Upload the code to your Arduino board. Step 4. Testing the system. Power up your Arduino and LCD. Hold an RFID tag near the reader. If the tag is authorized, the LCD will display access granted. If not, it will display access denied. Congratulations! You have successfully built a secure access system using Arduino, RFID, and an LCD. This project demonstrated how to build a basic but functional secure access system. We learned how to interface an RFID reader with an Arduino. We also learned how to program the Arduino to read and validate RFID tags. The inclusion of an LCD provided a visual feedback mechanism for the user. This system can be further enhanced in numerous ways. You could implement a more sophisticated database to store authorized tags. You could also add additional security features such as a keypad for a PIN code or a fingerprint sensor. With a little creativity, the possibilities are endless. This project serves as a stepping stone to explore the vast world of physical computing and security systems. By understanding the basic principles, you can adapt and modify this system to suit your own unique requirements.